Hello, hello, everyone. Welcome to yet again another Wednesday. It is time for Cataloging Cocktails. This is a weekly live hangout. It's an honest, no BS, no sales conversation about data management with our tasty beverages in hand. Today, I am drinking an Army Navy with soda. Juan, what do you got going on?
I'm going to make this right here. I'm doing one of my favorite drinks to do when it's a nice cold day. So it's a carajillo. So this is a liquor of 43. And then you put that with an espresso, kind of put it on top. And there we go. Nice.
Really?
Nice, fancy but not fancy drink. Anyway, cheers, man.
Yeah, cheers. Hey, everyone. Welcome, welcome. I'm Tim Gasper, Director of Product over at data.world. Juan is our principal scientist. And, we like to get together and we like to talk about data management. And we got some great topics today. But before we go into that, we do want to say that please join us. September 23rd, we have our first ever data.world summit. This is just your FYI on that. It will be a half day of ideas and guidance and journeys into sort of innovations around data and data practices, technology, leadership. You can register. You just go to data.world. It's the big homepage banner takeover right now, or you can go to data.world/events/summit. So please check that out. It will be an awesome event. And that is the one data.world specific thing that we're going to talk about right now. And make sure that y'all check that out. It's going to be a great event. But we've been talking about, last week we were talking about AI, and today we're going to talk about some more AI. We're going to talk about our robot overlords, and should we be bowing down to them or not?
Well, I think last week we were talking about crowdsourcing, where we kicked this off about, we wanted to talk about AI, but it's just such a large topic. And I actually got the textbook on artificial intelligence, a modern approach, right? This is your classic textbook, the Russell and Peter Norvig book. And I just wanted to really kind of start off. We all talk about AI and what is AI. And I think it's important to say, okay, what is actually the definition of AI? Let's put all the hype aside and let's go back to the textbook definition. I mean, simply, AI is, we want to be able to understand and how to build intelligent agents. And we want to be able to go build these intelligent agents such that their systems. And this is really interesting. We go back in history, there's 4 different areas that we categorize the definitions of AI. We have systems that can think like humans, systems that can think rationally, systems that can act like humans, and systems that can act rationally. So think like humans, act like humans, and think rationally and act rationally. So let's just put that as a perspective here, kind of to put as a baseline of what is AI, right? This is the textbook definition. And now there's so much stuff about AI. And now everybody brings in AI, and like ML and machine learning becomes a synonym to AI, which is not true. There's so many different areas of AI, and I think machine learning is just one type of that area.
Yeah, I think it seems like folks kind of, when they learn about AI and they get excited about what it can do, they tend to gravitate towards ML, and you even see that in the data management space a lot, right? There's a lot of like, what ML features does your platform have, and that kind of thing, right? And obviously, for most of you on this call, you probably already pretty familiar with AI and ML, but for those that are a little newer to the concept, I mean, you heard Juan kind of introduce it there. AI is really the sort of the superset, right? Where sort of any sort of automation, and whether it's trying to act like a human or it's just trying to make the right thing happen, do so without having to do it manually all the time. Like AI can take many shapes and forms, right? But machine learning specifically is more where you're creating a model, a statistical model, and trying to get sort of things to be automatically sort of applied or work to be done based on that sort of that model, right? And ML can take many, many different forms. There's all sorts of different algorithms that can accomplish machine learning. And even a subset of that is deep learning, right? And that's where you're actually using neural network approaches And for those who are not as familiar with sort of the rabbit hole that is AI, ML, deep learning, all that jazz, feel free to do a little Google through, and you can go down that rabbit hole at your leisure. But there's a lot there to unpack, and all sorts of ways that it can apply to the data management realm.
And Tim, remember, there's this other area of AI which doesn't have all that popularity right now, but it's always there, which is, let's call it the logic-based part, or the reasoning side of AI, right? This is where the rules come into place. Yep. And all the semantics where you can do inferencing. And these two things together are kind of, you put together, this is the AI that we're talking about. And because of the large amounts of data that we've been generating, I think the whole deep learning thing got so popular because you have ImageNet back almost like 8 years ago, started to create this gigantic database of images, and we started learning about that. That became the big boom of things being more about the data. But you have the data side, like I'll just call it the data side of AI, and you have like the more logic rule part of AI. And what we're seeing today is there's been all these advances. Kind of the rule side had a lot of advances, what's called during the 90s and through the 90s and early 2000s, and then during the 2000s, the data side got a lot of advances. And now we're starting to see how these two things realize that they need to work together, right? There's a lot of the common sense type of stuff that is part of the reasoning side of AI. Even though you can learn a lot of things, sometimes now you hear the explainability, right? How do I explain what this AI model is? Why is this happening? This is when the rules, the logic side of AI is coming into play. So that's a two-part to marriage. So kind of to set the no fluff part of what is AI here. So now let's bring this into data management and data catalogs and everything. And like we were talking last time, if we step back for a moment, why do we think about we need AI within an organization to help us? And essentially is that we spend too much time doing things that we believe that we should not be spending our time on, right? So if we go back to the categories of the personas, right? You have our data consumers, our producers, our consumer of data, for example, a data scientist, a data analyst. They need to go find data so they can go do their analysis, and they spend too much time finding their data. I want to be able to reduce that time. A data steward spends so much time documenting all the databases or the assets that they have under their control, assessing the quality of it, right? That's time that they don't want to go spend on that. A data engineer spends too much time providing access to all the consumers of data, saying, "Oh, you have access to this data set or not." So I guess the goal in an enterprise is that we want to reduce the amount of time that's being spent on tasks that we may consider a bit superfluous or just annoying, because heck, time is money, right? So the popular and now expected solution to this problem is slap it, AI. AI will help us do X, Y, and Z such that we spent less time on this stuff, right?
Well, that's the magic that everyone's hoping for, right? Is that, the data is growing exponentially. The use cases are growing exponentially, and humans are, in our companies are growing linearly, ideally, but probably flat or maybe even declining more likely, right? And so, when we think about, these use cases, you're exactly right, Juan. There's definitely this class of use case where it's, I want to take what humans are doing and I want to extend them. I want to amplify them. I want to scale them, right? Scale that manual effort or that rote effort or that maybe error-prone effort. And then the second class of things is, unlocking maybe insights and things like that it might have been harder for a human to determine, right? Can we use machine intelligence to help surface anomalies or things that, a human might miss, right? And I think those two things together seem to encompass quite a bit.
Yeah, so there are things that they're just tasks we want to be able to automate, but then there are things that it's really, really hard for us as humans to be able to go to. So
maybe there's too many variables at play or whatever it is, right?
Actually, both of us, we were meeting with some folks. What's it called? The company, Sisu.
Oh, Sisu, yeah.
Sisu, right? So we were meeting with these folks, and I really like their approach of how they say we want to be able to come. There's all these different variables that we want to go manage, but a human can't go do it. And the goal is to really understand the why. Why is the data trending one way or the other? Well, we can go in and go test out all these variables, but they're just going to be so many. But we want to be able to have an automated way to go in And what I really liked, what they were presenting is, you want to be able to have the human involved, right? Because the human, you want to be able to identify these things, but still pass this on to the human. And it's it's this, what you've called before, this collective intelligence, that you want to be able to combine the humans and the machines together. And I think another thing you just mentioned, Tim, was how do we scale humans? And so I think the premise is that, one, if we imagine the spectrum that we've decided before about humans on one side and machines on the other, right? We're not going to do everything completely automatic, completely manual. And this expectation that we can automatically do everything with a magic wand, that's really la la land. So we really need to go find what is that medium where we need to have humans, but we can't have them involved all the time. We need to go find that balance. And how do we scale humans here, but make sure that they're also part of the loop? So I think that's the crux, and that's what we're really gonna go do. And I tell everybody, if somebody's selling you some AI system that's gonna go do all this stuff magically, please be skeptical. Please be critical about this. Don't drink the Kool-Aid just like that, simply. Be skeptical.
Yeah, no, I think it's really important. And I think that, I really like this collective intelligence framework that we've been kind of riffing on here, where, there's sort of there is a little bit of human asymmetry, right? So you got more your top-down folks where there are experts, there are subject matter experts. They're the ones who, should be the ones who set the initial rules, or they, have pure edit rights onto your metadata or your particular governance processes. But, in order to have an environment of literacy and participation and really accelerating broader insights, we kind of brought up this idea of crowdsourcing. And obviously, for those who didn't check that out, definitely check out the recording of last week's episode where we talked more about crowdsourcing. But that does leave a third piece of this sort of collective intelligence triangle, which is automation, right? And there is AI, automation, ML that can come to bear on these different processes that can be quite useful. And, what are those use cases, right? Where can that be really helpful? And I think particularly here we'll try to explore a little bit more in the context of sort of, metadata and data cataloging and things like that. But obviously, these use cases can extend further, right?
You're talking about use case, and I think we need to step back for a second and look at what I would categorize as the two kind of big use cases. Is one, I want to do something with data. So give me my data, or once I have data, I'm going to go do something with it. I'm going to do my analytics. I need to go predict something. I need to go use it to go recommendations. I'm using the data, and I want to have my AI system, which could be powered by some machine learning techniques, powered by some inferencing, reasoning techniques. I want that to be able to, basically, input is the data and output is going to be something unique, something that a human could have not done on their own, right? That's one thing. Yeah. But the input to what we just discussed is data. So that's one thing. So it's the usage of data where the input is data and the output is going to be some insight, something to be done with the data that I learned. But the other thing we need to think about is, how do I actually create that data? Because we always talk about garbage in and garbage out. So then how do we actually create the data? And I think those are another set of tasks, which are different from the usage of data. So there are tasks that occur when you want to use data, but there are other set of tasks that occur when you want to go create the data, but you also want to be able to go automate those tasks. And when it comes to data management, the manage of data, the catalog of data, we really want to go focus on that, on the how do I create the data. Then you'll have other tools that will say, hey, give me the data. I'm going to go do something really smart with it. So yeah. So I think that's the two kind of different versions how I see the world. What's your take on that?
I think I agree with you, but your choice of the word create is interesting in terms of create data. Can you talk a little bit more about that? Like why do you say create data, and what does that mean for you?
Well, so I think that the ultimate application in that area is literally data integration for an enterprise, right? You have disparate sources coming from, you have different data coming from different sources. I want to be able to go integrate that and be able to, quote, ideally create my clean, understandable view of data. and I want to be able to automate that as much as I can. And there's going to be AI techniques involved in there. But then that's my creation part. And once that's there, I want to go pass that data on to other systems that are going to go do really cool, fancy automated stuff, and the AI will do that, right? So that's where I'm kind of using the word creation here, but it doesn't mean I'm creating it from scratch, right? I'm taking other data that exists that I'm integrating and putting it all together and creating.
Got it. Yeah. So it can be curating the data, connecting the data, elevating it, and then going into the management of it, right? And sort of the reuse of it, right?
Yeah. So for example, when we talk about like on the usage of the data, I mean, nowadays we have autonomous vehicles now, right? And they take as input sensor data, and their output right there is like the car knows where to go, how to stop, and so forth, right? Personal assistants like Siri or Alexa, right? They take as input your voice, and they can go translate all that stuff, and they make a decision on things, right? And the same thing, like we're going to do recommendations or predictions, and how can I improve my KPI and all that stuff. But the other sets of tasks I think are more related to the data management, data integration. I have to integrate heterogeneous schemas of data. I have different carriers of policies. I have different claims that come in. They all send me data in a different format, right? I have to do schema matching for that. Oh, I have to know that Bob Smith in this one database is the same Robert Smith in this other database. I get, for example, the data and data, for example, has a bunch of SIC codes or NAICS codes. How do I know that those NAICS codes associated with those companies are actually correct? Can I trust those numbers? Can I trust the codes that have been applied there? How do I know the data quality of that? Those are tasks I need to go deal with, right? So those are the types of kind of the tasks I need to go deal with. I'm kind of quote unquote creating the data. How do I know if there's PII information in here, right? And I think so. Those are the two types of kind of worlds that I see when we're starting about data. And when it comes to data management, data catalogs, metadata management, data governance, we're in the realm of the creation of the data. How do we best do that? How do we best automate that? And I think that's that's my perspective on this. So we need to separate this and see where everybody's interested.
Yeah. No, that's really interesting. And now that you say that, like I kind of see these things kind of splitting into two camps a little bit then, like similar to what you're saying. Maybe one that is more, AI as the product, where sort of the AI, the automation is the thing that you're trying to put out there. And then AI is the enrichment and the contextualization, right? And so in this context, specifically the enrichment and the contextualization, I think that's where we start to explore some interesting use cases. So you mentioned things like connecting and linking the data together, right? There's something really valuable and automatable, and sort of in sort of being able to not only connect data together, but create abstractions on top of that data. So that definitely seems like something, right? That is a key use case here where AI can really help. We talked previously about making manual tasks less manual, or at least, giving the ability to do things at a wider scale, right? Maybe that is sort of the bulk application of things. Maybe it is the, setting up of rules or something like that, right? That seems like that's another one.
I mean, so this is, I mean, you just said it, like, if we set up a rule, as simple as that sound, that is AI, right? And we want to go, we're providing a set of rules, we're inferring, if I see this, then do that, right? That as simple as that sound, that is AI.
Yeah, there was a good joke in the chat that said, if it's PowerPoint, then it's also AI. And that's funny. And I will say, but if you put in a macro in your Excel, or even if you put an equation in a cell, like it's like, well, that kind of is AI, right? Those are rules that we're applying as logic that we're applying. So sorry to interrupt, but I thought that was funny, a funny connection to what was in the chat.
No, I agree on that. And then, you can have rules like this, but you also want to be able to automatically tag things, right? So let's go back to the use case that you have a data analyst. They want to go find data. How do I best find data? I would be able to automatically add tags to data sets, and I want to be able to go search based on those tags. That can really reduce the amount of time, but I want to be able to automate adding the tags. But then, wait, are we going to automatically accept what what an AI system, machine learning system is going to return to me as tags. So imagine I have literally 1,000 data sets. I run it through my AI system, and it's going to slap 10 tags on each one. Are we done? Are we actually going to accept that? I mean,
well, I think that's where the human in the loop becomes pretty important there, right? Because I think,
and the crowdsourcing.
yeah, and the crowdsourcing, because if it's 95% accurate, that's great, but then you apply it to 100,000 assets. 5% of those 100,000 assets have been, misapplied, right? And then even in those another 95%, there's probably a gradient of how happy you are with the results, right? So I think that that's interesting, right? There's a challenge there, and it really puts a test a little bit to that collective intelligence triangle of how do you get those three things working together nicely?
And it goes back to what we were talking about crowdsourcing last week, which is, do you want everybody to be involved with this? So what if we say, you know what, I'm going to accept everything, or I'm going to accept everything that's 90% above automatically. Okay. People are going to go start searching for this, and they're going to say, wow, that's not what I was looking for. This was wrong. We should take that tag away. So that's where you want the collective intelligence. You want the users involved in crowdsourcing, saying, I'm going to eliminate this tag. And then the steward can come in and say, yeah, they're right. And I start getting, and guess what? You start realizing what are the data sets that are most interested. Even though you have thousands of data sets, you did not need to go spend all your time curating those 1,000 data sets. The collective intelligence, the people are the ones who are going to tell you, the crowd is the one who's going to realize, oh, these are the important things, and also help you kind of figure out what are those best tags.
Yeah. Well, and this was where we get into use cases again a little bit, because I think that tagging is a really good case study. Because if the goal is to just organize, if the goal is to curate, if the goal is to help people discover, because you want people to search on these tags, right? And maybe these tags are a little bit more abstract and more connected to the things that people are searching for than maybe some of the most catalogs these days have full text search. Certainly data.world does, right? But tags sometimes can be very effective. In those use cases, you're probably more tolerant of issues, right? If it's 95%, even if it's 80%, right? Like, even if sometimes it's tagging the wrong thing, maybe overall it's improving the organization of the catalog and the discoverability of the catalog. But imagine the use case was like sensitive data, right? And you're trying to identify, is it a social security number? Is it an email? Is it a phone number? Is it phone number adjacent? And social security, maybe it's a partial, but it's close enough that, it should be treated like sensitive, et cetera, right? Those are example use cases where maybe a probabilistic, this is like deterministic versus probabilistic. Maybe a probabilistic approach is not so good. And maybe you really need to do more of a deterministic approach. This is where rules maybe make more sense, regexes and things like that.
Yeah, and it's a combination, right? You want to have what's also known as active learning, and have somebody involved that will improve the algorithm, that will improve the model once it learns things, right? The human will provide some input, it will learn, right? The other areas of reinforcement learning is another area of machine learning where this happens. But so you have things like different tasks when it comes to that kind of the creation that I was talking about, the creation of data kind of bucket. We were talking about, I need to go tag data sets, identify if something has PII. But again, like data quality, we can go, like, there are things that we can go learn automatically. But then there are other things that, for me, we have such a big, what I would call an AI complete problem, which is, it's not even if we had general AI, it could be a solved problem. And these are things when not even the humans will agree on the definition. So for example, the example I always give, people have seen me, hear my talks and everything, is what is an order? What is a customer? What is net sales of an order? Not even the humans will agree what this is. Why the heck do we expect that the machine can come up with the correct answer? Now, let's assume that we could, if we have enough data, right? We're creating our machine learning models, we'll create a lot of data to be able to learn this. The thing is that we have a lot of raw data, a lot of rows, right? That's why we can do really well today, record linkage, entity linking, all that stuff. But we don't have enough metadata. We don't have enough schema matches, alignments, to be able to go learn all these or create a model to go learn and suggest what these mappings could be. We are really far away from that. And because it just takes so long to go integrate 2-3 databases, right? So we're never going to have enough metadata to be able to pull that all together. So I think that's one of the reasons for me that we cannot have yet an automatic AI system that can do schema matching. That's kind of my proof by example that I think this is an AI complete problem.
Yeah, that's tough. I mean, there's certainly some vendors working on that problem, right? Like the magic make your data all come together. Like, but
this is the stuff that I say we got to be skeptical about, right?
Yeah, yeah.
I can say, oh, F name should be mapped to first name and L name should be mapped to last name. Yes, and guess what? Most probably they did a lot of string matching to go do all this stuff. And also, guess what? In reality, probably 5-10% of your enterprise schemas are like that. But the examples I always give is you go look at any big database schema, an Oracle, EBS, an SAP system. You just have a bunch of attributes called segment 1, segment 2 with code names A, B, C that mean nothing. I mean, what does this data actually mean? It's all in some data dictionary somewhere else.
Well, and that reminds me that, at some point we'll have one of these sessions on master data management, because this starts to remind me of the problem set that master data management is trying to solve. And, there isn't that magic master data management button yet that you can press where all of a sudden all your data just magically turns into the golden record, right? It takes you got to build the rules. It comes bundled with rules, but you got to build the rules, right? It comes bundled with machine learning, but you got to apply it in the right ways, and then you have to know what order means in your organization, or how are you going to create a master data model for it, because it might be right for you, but it's wrong for me, right?
Well, I think this is also important. And we've talked about this in different sessions before, is that let's be transparent. It's okay if we have different definitions. We cannot start with expecting that we're going to have that clean definition from day one. And I saw somebody on the chat, I think Ilya was saying, I completely agree with this. A human should be the curator rather than the creator of these tags, right? Exactly. We got to go, we need to make sure that the human is involved. And how do we scale the human in this process? So I always ask myself, we talk about human in the loop, like, is it really human in the loop, or is it the machine in the loop? Like, what is the balance? And I think that's what we ultimately need to go find here is AI, automatic techniques, AI based on machine learning, based on rules, semantics, and ontologies. These will help us automate things. Depending on the use cases, depending on the users, we need to go find a balance of how much we can actually go fully automate, how much we can go trust that, how much the human needs to be involved. This depends on the success criteria that we want to go establish. So many different variables. It is not a silver bullet.
Word. Is it takeaway time?
Takeaway. Wow. You start.
Say two things. One is that, AI helps, right? AI helps. It helps with discovery. It helps with trends. It helps with making manual tasks less manual. It helps with connecting and linking your data together. And you can see how AI and then, a subset of that, machine learning, can have an impact on your metadata and your data to help, right? To scale humans. But AI is a tool. And that tool can work out well, or it can be a distraction, and be skeptical, and be use case centric. That's my takeaway. Sort of a long one.
So I was going to say the same thing about be use case centric, be skeptical, be critical. Again, be skeptical, be critical about anybody who's selling you some AI system that's going to magically do everything. There is a hype, but it is reality. There are so many different types of AI techniques that are here. It does help, but I think we really, by being critical and skeptical, we need to understand that the humans need to be involved, and we need to figure out what's the best way of having humans involved such that we can scale the humans and be successful, which means we need to go define what success means, which means we need to be use case driven.
Yeah, I love that. And maybe also measure. Right.
Yeah,
that's a good way.
Always measure. I mean, at the end, that's how we define success. Is we need to have a way to measure things. Let's go take a baseline that we can quantify. We're gonna our hypothesis is that we're going to go do X, and then we can go measure X and compare it to our baseline. That's how we know if we're being successful and how successful, and even if it's worth going down this path or not.
Yep. Is it speeding us up, and are we achieving better outcomes? Right.
Tim, always a pleasure. You have a great one. Talk to you next week.
Absolutely. You too.